In this video, we will discuss common misconceptions with cones and pyramids. Now, one of the key concepts we need to know in order to be able to deal with many of the problems with cones and pyramids is Pythagorean theorem. So the Pythagorean theorem states that a squared plus b squared equals c squared, where c is that side across from the right angle, or the hypotenuse. Now, in a square pyramid, there's three important things that you have to know. One of the important dimensions is the side length of the base, which for example would be something like this or this. So one key measurement we have to know is B, which is side length of the base. We also have to know H, which is the height, or that true height from the top of the pyramid to the base, forming this right angle. So we need to know H, which is the height. And we need to know this length L, which is what is referred to as the slant height, because it's the height of that slanted side. So we have L, which is our slant height. Now, in the first question for the Google form, it gives us this pyramid. Now, if we're just using our formulas, we know that the length of B, which is the side length of the base, is 9 yards. Because this is given as 9 yards, so we can assume that this is also 9 yards. That's our first measurement we have to know. The second one is the height, H, which we don't know. So we can draw it in because we are going to need it eventually. So that would be our height. And the last measurement that we have to know is the slant height, which we have is this length of 10, which we could also draw in over here. So this has a side length of 10 yards. So L is 10 yards. Now, if we want to solve to find this height, what we can use is, so for example, if I label this as H, we know that the whole side length of the base is 9. So if I were to draw in a side that's parallel to this and I split 9 in half, it gives us 4.5. So this is 4.5 and this is 4.5. So now looking at this, I have a right triangle. And I can redraw my right triangle over here. So I have that this is 4.5, this is 10, and this is the height H. So I could use Pythagorean theorem to say that 4.5 squared plus H squared equals 10 squared, which would give us that H squared equals 79.75. And if you square root both sides, you'll get that H is equal to a decimal, which we're going to round to 8.93. So our height of our figure is this 8.93, which we can now go back and use the formulas to continue solving. For this example for number 2, for the Google form, the length of the base is 14, as is shown here, which means that this side length is also 14. So I can label this as also 14. The height is this vertical dimension, which is given as 12. So I could say that H is equal to 12. And lastly, the slant height is the height of the lateral faces, which we don't know. So I'm going to call that L, which is unknown. However, like we said before, since this whole side length is 14, if I draw on a side parallel, since 14 over 2 is 7, I know this part is 7 and this is 7. So this gives us a right triangle right here as I'm highlighting. So if I redraw the right triangle, so this is 7, this is 12, and this is L. So we can use Pythagorean theorem to say 7 squared plus 12 squared equals L squared, and you could solve to figure out what L is equal to. So if we want to deal with our formulas for a pyramid, we have the base, which is a square where both sides are b. So the area of the base is always just b squared. The lateral area is 4 times the area of one of those triangular faces. And based off of what we have, this is the side length of the base. And the height of those lateral faces is the slant height. So the lateral area is equal to 4 times the area of this triangle. Now for surface area, equals the lateral area plus the area of the base, which we've already shown how we can find both of those formulas. And lastly, our volume equals 1/3 the area of the base times the height. However, you have to make sure that you are using this height from here. And we can use these formulas with the information on the previous slides to make our calculations. Now, for a cone, our key dimensions are very similar. You have your radius, which is the distance from the center of the circle to the edge of the circle for the base. So we have r, which is the radius. We also have the height, which they have drawn outside. However, it's typically drawn on the inside. So this is h, which is the height. And we also have our slant height, like we had for our pyramid. So L is the slant height. And we realistically have 2 radii at that base. I have the radius that goes in this direction, and I also have a radius which extends here. Now for this example, if we're talking about our key measurements, we have our radius is given right here. So r equals the radius, which is 5. Our height, we don't know because it's this measurement right here. So this is h. And our slant height is given to us as 12.1. So L equals 12.1. Now looking at this, we have a right triangle because I have this is h, this is 5, and this is 12.1. So we use Pythagorean theorem with 5 squared plus h squared equals 12.1 squared and solve to figure out what h equals. For this example, for problem B, if I look at what I'm given the radius of 8. So r equals 8 miles. The height is given to us as this side length of 16. So H equals 16 miles. And my slant height is this length here, which we don't know, but we can call L. So if we want to solve for this, we can use the Pythagorean theorem. So this is 16, 8, and L. So I can say, okay, 8 squared plus 16 squared equals L squared, and solve to figure out what L equals. Now that we have this information, we can apply it to our formulas. So for the base of a cone, it's always using this radius. So the area of the base is always pi times the radius squared. The lateral area uses the formula pi times the radius times the slant height, L. So once we solve for L, we can use that. And our surface area equals the lateral area plus 1 base. The volume is 1/3 the area of the base, which we found the formula for above, times the height. But again, you need to make sure you are using this height. Once you have that information, you can use that to apply to your formulas. So essentially, as the key takeaway from this video, whether you are given the height and need slant height, or given slant height and need height, whichever you are doing, the key thing is that when you get stuck, you need to use Pythagorean theorem and be careful about which height you use.